Hello, dear students. Okay, we are entering now the final stage of the project of the COVID infection and disease rates to measure against the population density and the total population of each country of the world, okay, in groups. So I have run the numbers and come up with the results, but I want you now to run the numbers too to see what results you come up with, okay? And basically, this is the idea. We have essentially four categories. We have the number of infected people, the number of deceased people, the number of people in the country, the total population, which I'm just abbreviating as POP, and then the population density. Population density, if you remember, is the number of people per square kilometers, since we're working in the decimal system, okay? So these little tables, what I've done is I've run the correlation between categories. For example, the number of infected versus the number of dead. And so this number here in yellow is the correlation coefficient, 0.93, which is a very high correlation coefficient. That is expected because these are deceased people of the coronavirus infection, okay? So we expect a very strong correlation between these two categories, the number of infected and the number who have died from those who were infected, obviously. And so we see that there is a very strong correlation there. I'm going to stick with the first table first, and then I'll get to the other four tables. What may be surprising is that the relationship between the population density and the number of infected or the number of deceased seems to be essentially no relationship. And if anything, it's in the negative. It's an inverse relationship. But the number is so small, 0.04 in both cases for infected and deceased, that essentially we can say that there is no relationship between the population density of the countries of the world and the rate of infection or the rate of disease. This is counterintuitive in the sense that we were expecting, the expectation was that the more densely populated a country was, that the higher rate of infection, since it is transmitted person to person, right? So this number, this very low association or essentially no correlation between population density and number of infected and number of disease is counterintuitive. Yet I have an explanation for it, right? But I want to hold off until you run the numbers yourselves and get the same results. Okay, then the next category is the actual number of people in the country, not the density, but the absolute number of individuals in each country, what we're calling the total number of the population, right? When we do that correlation between population and infected and population and disease, we get various results. Some, a loose association, first of all, they're all positive results, all right? So there's some kind of association or relationship, and it is a direct relationship, not an inverse, in the sense that the greater the population, the greater the number of infected and greater number of disease, and not vice versa, okay? So it's a direct relationship as opposed to an inverse relationship. But then it varies between the size of the population. It turns out that the size of the population makes a difference. And we had no idea about that until we do the statistics. So the statistics are revealing that depending on the population density, there is a stronger relationship between the total population and infected and deceased, depending again on the population density. You'll see what I mean in a minute. But basically, we have to look at this cell over here in the B column. This one says total. This is the total number of countries, which is about 230, right? Then the next four categories, you see it varies. It says here above 1,000. It means that these countries here are the few countries that have a population density above 1,000 people per square kilometers, which is about a dozen countries, okay? So it's not a large number, it's about a dozen countries. Then this category here, below 1,000, is the complementary of this one. In other words, the other 220 countries, more or less, that have a population density less than 1,000 persons per square kilometer, okay? So when we add these two numbers here, above 1,000 and below 1,000, we get the total number of the population. Again, these countries here are about a dozen, and then the remaining to 230, these countries are about 220. All right, then these other two categories here, above 200 and below 200. Again, the same criterion. The 200 is the 200 persons per square kilometers. So this is a density relationship, right? In other words, this is 200 persons per square kilometer. Above 200 persons, which is about 70 countries. 70 countries are above 200 person per square kilometer in density. And then the rest, which is about 140 of them, it is below 200 persons per square kilometer, all right? So about 1/3 of the countries have a population density above 200, and then 2/3 of the countries of the world have a population density less than 200 persons per square kilometers. When we do these stats, we come up with a drastic difference. We see a generally strong correlation between the number of people in the country, between the population, and both infected and deceased, as you see here, but then a very weak relationship when we go below 200 persons per square kilometers. In other words, when we go to low density, we see a very loose relationship, very light relationship between population and infected, all right? Again, this one is expected because low density. So, and the reason why I did this division, why the 200, I'll show you a graph in a minute, because when we plot population versus density, we see that these below 200, it's a fairly linear relationship in population. But above 200 density, the relationship is more a logarithmic relationship. It is a power relationship. It is not linear. It's not one-to-one, okay? So there was some significant difference in the population number between these two categories. And when I ran the numbers in StatCrunch, in fact, I got a very different type of relationship. Above 200, as you can see, strong relationship, and below 200, a very weak relationship. All right, so this one is also significant here, this number, population density of 200 for the countries. Okay, so I'm going to send you the data, what I have done, for example, to get the total 230 countries, I just added all the data that you had, because each one of you had about 40 countries. So I made a master list of all the countries, including the data that you each did for your own countries. All right, so I made a master list for that. And that is how I have the total 230 countries in a single spreadsheet. All right. And then for these, I simply cut off from the spreadsheet those numbers that were below 1,000, those countries that were below 1,000 density. which, like I say, it's about 220 countries that I cut off here because this is only a dozen countries. So this is a short list, if you will, in this spreadsheet. Then this one, of course, I cut off the countries that are above 1,000, which is this dozen countries here. So this list has about 210 countries on it. Then, like I said, these lists here, this has about 70 countries, those who have a density above 200. And then this list has about 140 countries, the density below 200 people per square kilometers, okay? And so we come up with 5 data sets here, 5 data sets, the total data set, the dozen countries, the 210 countries, the 70 countries, and the 140 countries, okay? And so I have subdivided them into each one of you. So I just went alphabetically here. Brianna, you'll work with the list of the total number of countries. Daniela, you'll work with the list of these countries here. Galilea with these countries. Jose, these countries, and Nicole, these countries. So what I'll do is when I send you the email, this will be a global email with this little video for everybody. And then I'll send you individually your data set to be used in StatCrunch. So basically what you need to do with this new data set that I'm sending you is upload it to StatCrunch and run the numbers, all right? Again, you should be getting these numbers, okay? But if you don't, it's okay. We'll go over it and we'll see who made a mistake, all right? At any rate, I'll send you this PowerPoint also, but I want to see on the, I want to see on your screen, when you send me these results, I want to see on the screen the actual StatCrunch statistics, okay? To make sure that you get the right numbers. Okay, so again, what I'm going to do is I'm going to send you each your data set, which will be an Excel spreadsheet, loaded up to StatCrunch, just like you did before, and run the stats. In other words, you have to run 5 stats, 5 correlation coefficients, all right? And your columns here, your 3 columns, these are going to be your x-axis. In other words, your x-axis is going to be infected, and you run it against the number of deceased on the y-axis, and that's how you come up with this number. The same here for density. You put density on the x-axis, right, which is the independent variable, and then the number of infected is the dependent variable, the y-axis, also for deceased. And the same argument goes for population. In other words, you put population on the x-axis because it's an independent variable, right? There's people in the country, in any particular country, there are people walking around, whether they're infected or not, they are the number of people in the country. So this is the independent variable, right? Just to finish up then, between infected and disease, how do we determine which is the dependent and which is the independent variable? Well, consider this, is the number of infected dependent on the number of deceased, or vice versa, the number of deceased dependent on the number of infected. I hope you understand that of these 2 numbers, the larger number is the number of infected, right? Because the deceased are deceased from being infected, but not all infected are deceased. So of these 2, the independent variable is going to be infected. And then of those infected, some have died, so that's the dependent variable. They died because they were infected. So deceased are dependent on infected. They had to be infected before they died, all right? So that's why I have these 3 categories up here as the heading of the 3 columns, because these are the 3 independent variables. And then the others are dependent. All right, so run your stats and get back to me soon, because now we are basically ready to close this up, all right? I'm also working on the abstract so that we can have it out there in a timely fashion. Thank you once again. If you have any questions or call or comments, as always, you can text me or give me a call. All right. All the best now. I'm going to close the video. Bye-bye.